everybody, it's Miss Phoebus, and I'm back with another lesson. This is lesson 66, Box and Whisker plots. So we are still representing data with plots. We've looked at dot plots and histograms and stem and leaf plots, and now it's time for box plots, or box and whisker plots. And it is still a part of this standard where we have to represent single or multiple data sets with, in this case, a box plot. We're on page 334 if you're following along in the notes. And box and whisker plots are a graphical display of the 5-number summary. Remember we talked about the 5-number summary? The minimum, Q1, the median, Q3, and the max, the 5-number summary. They're useful when comparing groups. They're particularly good at pointing out outliers. And box plots are easy to make and useful in creating comparative displays. So it goes back to they're useful when comparing groups. So we have the anatomy of a box and whisker plot. You start with your scale. So you start with some kind of number line. We have on the left, we have a horizontal box and whisker plot with a horizontal scale, but you could also see to the right, you could have a vertical scale if you would rather do so. Notice that the intervals on the number line are evenly spaced. We're counting by the same number, so we're not sporadically putting in. A lot of times what people do is they just use the 5 numbers from the 5-number summary, put those down. That's not what we're doing, because then you can make your box and whisker plot look like anything. We want to pick numbers that are going to be representative of the data, right? We want to pick numbers that the data uses, but we also want to create this scale where we can go and compare two box and whisker plots very similarly. All right, the box represents the middle 50% of the data. So what a box and a whisker plot does is it divides the data into quartiles. So the first whisker that we have here, I'm going to draw on this one. This whisker represents 25% of the data that happens to be in the first quartile. And then this piece of the box represents another 25% of the data that is in the second quartile. This part of the box represents another 25% of the data, which is in the third quartile. And this part, the whisker, represents another 25% of the data. So then that means the box represents the middle 50% of the data. The whiskers, of course, go on either side of the box, and you can have 2 whiskers, but you could also have 1 whisker or even no whiskers. For the graph on the right, see the little dots that I'm pointing to here? These are outliers. And then we have Q1, the median, Q3, our minimum, and our maximum, and there is our display of the 5-number summary. So if you're wanting to compare medians and you have a box and whisker plot, you can do that. If you want to compare interquartile range, you can do that, right? That's Q3 minus Q1. If you want to compare maxes and mins and ranges, that's all going to work out. But there are going to be some things that are a little bit more difficult, like mean's going to be a little bit more difficult to figure out. Standard deviation, you would need the data set for that. So these are good at comparing lots of things, but not everything. So we do have shape of box and whisker plots. So for the one on the very left, you see how there is a larger span, like a wider range on the left-hand side. This 50% is a whole lot larger than this 50%. So that means that it's skewed to the left. That's like having most of your data here, and then your tail goes off to the left. The median is closer to the right-hand side. Now, when they're pretty even, we have symmetric box and whisker plot. The median's in the middle, the whiskers are evenly distributed. You could also have a roughly symmetric as well. All right. And then when my larger 50% is on the right and the smaller 50% is on the left, that's going to be skewed to the right. This whole skewed negatively and skewed positively is new to us, so we'll talk about that in just a second. The median is closer to the left-hand side, so then it's skewed to the right. So you have more of your data here, and then it trails off to the right. So this whole skewed positively, skewed negatively is a different way to say skewed left or skewed right. And if you think about skewed to the left, the negative numbers live to the left of the number line. So negatively should make sense there. And then positive numbers live to the right of the number line, so skewed positively kind of makes sense there. So it's just another way to say it or indicate it. All right, so we're going to look at steps to creating a box and whisker plot. So we're going to use the calculator. We're going to find the 5-number summary. Once you have that, you're going to decide whether your plot's going to be horizontal or vertical. That's kind of a personal choice. You're going to draw a number line and create a scale. Again, this is, you know your min, you know your max, you know how far those numbers need to be apart. You're going to count by the same value to create a scale. You're not just going to put the 5-number summary on there. That's not going to work. Don't do that. I will take points off. All right. And then you're going to sketch the pieces of the 5-number summary, connect them into a box, draw out the whiskers if there are any. Remember that you're not required to have whiskers. All right, so we're going to construct a box and whisker plot of the data. Now, be very careful because tables that look like this often lead people to think that it is a scatter plot. So just keep that in mind, that this is just one variable data. So let's break out our calculator. And just like we've been all this week, we're going to hit stat and enter. We're going to fill in L1 with our data values. So I'm going to go ahead and do that. You should do that as well. You should pause the video and fill those in now. All right, you're back. So we have our data in the graphing calculator, and we're going to hit stat, right, and 1 for one variable statistics. That's where we find our 5-number summary. And what I'm going to do is I'm going to go ahead and scroll down, but I'm going to also write my stuff over here so that I can get it out of the calculator and then focus on drawing my graph. So I've got and you need to probably label min of 9, Q1 of 10, median of 11.5, Q3 of 13, and a max of 15. All right, so with that information, we are going to create a scale, and then on that scale, we are going to create a box and whisker plot. All right, so I'm going to evenly space these out. 13, 14, 15. Okay, I feel that those are spaced pretty well. All right, so what we're going to do is we are going to make above our number line, not on the number line, above our number line, we're going to make some little vertical bars. So I have a min at 9, so right above 9, I want to do a vertical bar. And then right above 10, I want to do another vertical bar. That one's a little wide, so let's fix that. Do another vertical bar right above 10, and then 11 and a half. So I'm going to have to estimate. I'd say that's about 11 and a half, and then 13, and then 15. Okay, so there are our 5-number summary. And then the middle 3 are Q1, our median, and our Q3, Q3, and median. We connect them into a box, and then we connect the box to the min and the max with whiskers. So if our Q3 and our max happen to be the same, or our Q1 and our min happen to be the same, then we wouldn't have a whisker. But this is our box and whisker plot with 25% of our data between 9 and 10, another 25% of our data between 10 and 11 and a half, another 25% of our data between 11 and a half and 13, and our last 25% of the data between 13 and 15. So we have this value is a lot wider than this value. So if we were going to talk about skewed, it's skewed to the right or skewed positively. All right, we're going to do another one, construct the box and whisker plot. So we are going to go back to our calculator to get our 5-number summary. All right, so I'm going to type these in, and I want you to do so as well. And when you unpause the video with your data, I should be ready to go with my data. All right, I'm back with all my data in, and I'm going to do my 5-number summary. So I'm going to hit stat and right and 1. I hope you're doing that as well. And then there's our mean, we don't need that. There's our standard deviation, we don't need that. But this stuff down here, this is what we need. Now there's a wide bunch of numbers between 123 and 203, so we're going to have to consider that when we make our scale. I'm going to write all this stuff down. So minimum is 123, Q1, 150, median is 176.5, Q3 is 190, and then the max is 203. All right, so I've got to get from 120s to a little bit over 200. So I'm thinking maybe counting by tens. All right, so I'm going to put 120 here. I know that 120 is smaller than 123, but remember I'm going to count by tens. So it's a little bit easier to count by tens if you start with nice round numbers. And I'm just trying to evenly space these out. And I am actually going to go past 200. Added some extra line. I could shorten this. You could leave it. It's up to you. All right. So now we're going to have to estimate where these are. So 125 would be about right there. So I want something a little bit less than that. So I'm going to say this is about 123. 150 is right on the line, so that's going to be right there. 176.5. So here is, I don't know, that would be about where 175 is. So I might go like right here. Let's try that again. Right there, a little bit beyond that. 190 is right there. Here's 205. So 203 might be like right there. All right, so the middle three, we don't have any repeats, they get to turn into the box. Here, my whisker is a little funny. Clean her up a little bit. And there we go. And since this chunk of the data is a lot shorter, right, than this, that means that this is the tail. And so that would mean that this is skewed negatively or skewed to the left. And you don't always have to talk about shape and stuff like that, but I did want to just show you some different examples of that. All right, so the box and whisker plot is a graphical display of the 5-number summary. All right, let's look at graphing on the box and whisker plot on the graphing calculator. It's very similar to what we did yesterday with the histogram. You're going to hit second y equals. You're going to make sure your stat plot is on by pressing enter. And then remember how we went in and we changed it to a little histogram? Now we can choose it to be a box and whisker plot. We actually have two options. So we're going to choose the box plot, press enter, and then make sure there are no graphs in your y equals. That will graph over your box plot. You're going to hit stat and enter, and then you're going to type all your data into L1, but not into L2, right? One variable statistics. And then you're going to hit zoom 9. So very, very similar to what we did with the histogram and even with the scatter plot. It's just a little bit different. So let's work on getting this. Now, like I said, there are two options. I'm going to show you both, but usually I do the one without the outlier, just because that's normally what's needed. All right, so I'm going to put in my data. I'm going to pause the video so you don't have to watch me putting in my data, but I do believe this is data that we looked at with a histogram yesterday. All right, so I'm back. I've got all my data in. And what I'm going to have you do is, if you feel confident that you could pull up the box and whisker plot just based off of what we've done before, as well as what I told you about the graphing calculator, I want you to pause that and I want you to see if you can figure it out. If you're like completely not sure, then stay with me in the video. But how you develop your learning process is by actually trying to do things on your own, hopefully not getting too confused. So if you're going to try to do that, go ahead and pause the video now. All right, so we're going to hit second, y equals, and we need our stat plot to be on. I'm back to a scatter plot, so I definitely want to change that. And so we're going to hit enter, and then make sure that this is on. So if yours is off, make sure you hit enter again. And then we are going to come down here to type. So remember that there are two types. There's one, the one here with the dot, and the dot is the one that shows the outlier. And the one here is the one that doesn't. And so usually the one that I choose is this one, and I'm going to select enter on that one. But if you want to be able to know if the calculator thinks something's an outlier, then you can use this piece to look at that. So we're going to look at both of them in a second. And then we're going to hit zoom and 9, and there we go. Notice that we have 50% of the data in this region and then 50% of the data in this region. So I'd definitely say it would be skewed to the right. If you hit trace, you can rotate through and see what did they use: min, Q1, median, Q3, max. We are going to build the box plot, but we already know these things, so we'll just have to create our own scale. Again, we're not going to use the scale that, notice here they've got a lot of little numbers in between, so I'm not just going to use any numbers or even the 5-number summary. I'm going to definitely create my own scale. But I do want to show you what happens if you choose the other box and whisker plot option. Zoom and 9. And what it'll do is it will cut that box and whisker plot short and make this an outlier, because it is. It's a 68. Everything else is in the teens and 20s and 1s, and 68 is an outlier. So what it does is it removes the 68 as an outlier, creates a new max, which is 28, and then puts this as a dot, so you don't get that all the way across. And then that kind of helps focus this to where if this point was here, then it might be skewed left, right? Because the distance between the median and this point is a lot shorter than the median to the minimum. So that is an option, but most of the time, I mean, it just kind of depends on what you're being asked about. And then if you wanted to know if the calculator thought something was an outlier, you could use that part as well. But I'm going to use this, and we can even do stat write 1 and get our numbers if we are going to make the actual graph ourselves. So I'm gonna make it like we're making it on our own, because I don't really feel like it's much harder than sketching what's actually on the graphing calculator. And we got 68 as our max. So I'm probably going to count by tens again. So I'm going to put 0 here, 10, 20, 30, 40, 50, 60, 70, and then just estimate. So 9's about here, 15's here, so 15 and a half is really close by. Here's 25, so I don't know, right there is about 21.5. Here's 25, and 68. It's like over here. Okay, now if you're going to be just copying it down because that's what it says, you just need to do the rough graph. You don't have to do the scale, but you definitely need to make sure that this is kind of exaggerated compared to the rest of the box plot, because there is an outlier, so don't make it just like kind of long, make it pretty long. Just kind of keep that in mind. All right, so using a graphing calculator, construct a box plot. So same thing, we're just making another one. So, oh yeah, so this is 2 variable data, right? But what we want is we really just want to compare the shark attacks. So even though it gives us this, we can't build a box plot with both of these. So what we're going to do is we're going to focus on, yeah, we've got years since 2001. That part's not important. This part, the number of shark attacks in Florida, that's the part that we want to make the box plot of. So we want to go ahead and use that component. So really watch out, because if they're giving you information to make a 1 variable graph, 1 variable display, like a dot plot or a stem and leaf plot or something like that, but then they give you 2 variables, you have to know which variable is important. And so really the graph of the shark attacks in Florida, that's the part that they want to see. So we're going to hit stat and enter. And this one's long, so I'm going to have to move the calculator out of the way. 29. All right, so stat. And then, oh, we're doing zoom 9. That's what we're doing. Okay, so I would say that the left side of the box and whisker plot, to the left of the median, so to the left of this line, is longer than to the right of the line. So I would say that this is skewed to the left. If I was going to create this and not have my scale and like this is a true estimate, so I'm going to create a box and left some room to make my whisker. I would say that that's probably about halfway, so halfway would probably be about right there, so I'm going to cut it right there, and then my whiskers kind of, whoop, there we go, my whiskers kind of look even other than that, but that's going to be my estimate. One of the reasons why you should do it in the graphing calculator instead of by hand is just to get an idea of what the shape is. That's, I think, the best reason to do it in the calculator. All right, so a side-by-side box and whisker plot, you need only 1 scale. It's hard to compare them if we have 2 box and whisker plots on 2 different scales. We want them to be on the same scale. So here we have 4 courses that we can compare, and we can see where the medians are, and it's easier to see and compare them because they are on 1 scale. You're going to label each box plot so you know what data sets are being compared. And then you can have outliers shown. You don't have to. It just kind of depends on what's going on there. But it is possible to have the outliers, and sometimes you see them as little stars, sometimes you see them as circles, but they are all about the same thing. So this would be like data in L1, L2, L3, L4, and we're comparing it. All right, so 75 college female students and 24 male college students report the cost in dollars of his or her most recent haircut. The resulting data have been analyzed. Using this information, we're going to create a side-by-side box and whisker plot to compare the two groups, and then we have some questions based off of that. So we have the min, we have the max, we have Q1, median, Q3, and the mean, which I don't think we need the mean for a side-by-side box plot, but interesting. Okay, so we need to be able to fit both of them on there, and so we've got to go from 0, which both of them have, to 150 as well. So we need to probably count by, I would say, 10s, but maybe even 20s, because we've got to be able to we've got to be able to fit quite a bit of data on there. Now you have some options. When I create my scale, we can do like the females above the number line and the males below. We can do them on the same side. I usually do one above and one below. So I'm going to start here at 0. I'm going to count by 20s. So I'm even going to do like a little halfway mark. So that's 20. So there's 10. There's 40. 60. It's probably not the best, but all right, that'll fit 150 on there. I tried to equally space them. All right, so I'm gonna have, for my females, 0. My Q1 is 20. My median is 31, so there's 30, so I'm gonna just do a smidge over. Third is 75, so there's 70, there's 75, right about there. And I apologize if they're not lining up exactly. And then 150 is right there. So do the box, put females. All right. And then we're going to come back through, and on the other side, I'm going to put the males. So I've got 0, 9.25. So there's 10, so 9.25 is about right there. And then 17. So there's 15's about right there. So 17's there-ish. And then 20. And then the max is 35. So there's 30, there's 35. I think the females are paying way too much for their haircut. So this is males. And so now we have a side-by-side. I probably should have made the vertical bars a little bit longer, not to make the guy's box and whisker plot look way too small, but it's definitely a lot shorter width-wise than the female's box and whisker plot. So how would you describe the difference in haircut costs between males and females? Be sure to discuss your differences and similarities in the shape, center, and spread. So females pay a wider range of values than the males. And I would even say here's the median, and here's the median here. And on average, more than males do for haircuts. And that kind of makes sense because you go to a salon versus a barbershop. You kind of, guys don't usually have a lot of hair, usually, not always, but it just kind of depends. And then, you know, do females want more complicated things? Does that mean it costs more money? I'm not 100% sure. I'm not a hairdresser. I'm also one of those people that pays like $0 in the female range to get her haircut. But if you notice that the box and whisker plot for the females is a lot wider, everything's tending to be a lot higher priced than the males. But you do have this, even though that is true, this piece is a lot narrower, a lot condensed than this piece. So that means that there might be an outlier for some reason. We're not 100% sure, but I don't suspect too many people are paying $150 for a haircut. So I would say this one, the females is skewed to the right, whereas the males looks like it, I don't know, it's skewed to the right a little bit, but it's pretty symmetric-ish. Well, I'd say it's skewed to the right. So there are a few men paying some upper end prices. Why is the mean greater than the median for both the males and the females? Okay, so they want us to compare. Here's the mean, here's the median, here's the mean, here's the median. So why would the mean be greater? Because it is skewed to the right. Or you could even say because it has upper end outliers, which is what that kind of means, is that we have some people that are willing to pay those extra prices to get their haircut, and so they're not necessarily throwing things off, but they're pulling on that mean value. So when you talk about mean being kind of the average, and then choosing, median over mean, kind of keeping the outliers out of things. It's not necessarily that we are frowning on the outliers, that, oh, those people shouldn't, spend $150 on haircuts. It's just that's out of the norm. All right, so here we go. We have 2 colleges, GPA for 2 classes at 2 colleges, and we can see the max, that's up here at the high level. We can see the min, we can see the median, Q1 and Q3. So which data set has a greater median, college 1 or college 2? So we're looking at this bar that's in the middle of the box. So this is further up the scale than this one. So college 1 would have the greater median. Which data set has the greater IQR? All right, so IQR is interquartile range. That's Q3 minus Q1. That's the width of the box. So basically, which one has a wider box? College 2 has a wider IQR. Which data set has a higher GPA percentage above the median? All right, let's compare boys and girls. Which is truer and why? The girls are taller on average. I would say probably not. The median is lower, the minimum is lower, the maximum's lower, the minimum's lower. I'm going to go false with that one. The boys are taller on average. Well, that's kind of the opposite of that one, so let's go true. The girls show less spread in height, so that would be the range. So we're about from 180, not quite 180, to about 135-ish. So what is that, like 45? And then from here, that's about 185 to 135, that's 50. So yeah, I would say they show less spread in height. So that one would be true. The boys would be false. The shortest person is a girl. Yep, right there, the minimum. The tallest person is a boy. True, because there's the maximum. Both data sets are skewed to the left. So this piece is shorter than this piece. I agree for girls. This piece is shorter than this piece. I agree for boys, so that is true. Half the boys are over 172 centimeters tall. So I'd say that that's about 172. So this would be 25, and this would be another 25%. So that would be half, 50%. I agree with that one. Half the girls are under 165 centimeters tall. So here's 165. It's not quite lined up with that. So I would disagree with this one. It's very close. Maybe if they said 166 centimeters tall, but that would put the median here to make this true, and that is not 100%. So number 9 is false. So make sure you know how to read and make a back-to-back box and whisker plot. Make sure you understand the idea of the 5-number summary and what this is a graphical display of. And make sure you understand that the scale cannot be anything other than numbers that you use, but you're counting by the same value. You are not using, do not create me a scale that has the 5-number summary on it. No, 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 don't do it. All right, guys, tomorrow is the end of course. I am so looking forward to getting that over with, and I hope you are too. But stay positive. You've learned a lot. I've tried to do my best to prepare you the best I could. I know virtual learning has been tough, but I think for those of you that have stuck with me, I think that you've done very well for yourselves, and I hope that you feel confident as you go into this test. Please let me be nervous for you. I know that you're really worried and things like that, and I totally understand that. But I really want you to go in and, you know, believe that you can do it, because that's a big chunk of math, is believing that you can do it and trusting yourself and having confidence. Don't be too overconfident is also bad. Just be like middle confident. Be like, okay, I've learned a lot. I'm going to try my best on this test. And that's all I need from you. That's all I've ever wanted from you. All right, guys. I will see some of you tomorrow at the test. So I'm looking forward to that. And if you've got a graphing calculator, bring it with you. Let's see, what else can I eat breakfast. If you don't eat breakfast, there's breakfast in the cafeteria, so you can get some there. We will feed you lunch. New thing, you're staying until 2:45 unless somebody picks you up, so you might want to figure that stuff out as well. If you have any questions about the EOC, by all means, email me. All right, guys, I'll see you. There's one more video. I'll see you in the next video. Bye!